All right. So, you should have now read modules 4 and 5, and today we're primarily going to be talking about module number 6, but I wanted to take some time to really talk about the idea of a random and a representative sample. This was hit on when talking about surveys, but it's super important not only in a survey, but in any sort of research that you're doing where you're trying to apply the information that you have with the group that you studied to a larger population. Okay, so let's break this down thinking about online learning and our own school community. So let's say I'm a researcher and I want to know how effective online learning is for Carondelet and De La Salle students. My target population is Carondelet and De La Salle students. I want to be able to apply whatever I research to that population, all Carondelet and De La Salle students, okay? Two ways I can do this, a random sample or a stratified sample. In a random sample, I would take a list of all Carondelet students, of all De La Salle students. I'd make an Excel sheet of all of their emails. I'd alphabetize it. And in order to randomly select students, let's say I choose every 5th email on my list, and I would ask those students to be a part of my survey on how effective online learning is, okay? So the students that were pulled out of my Excel sheet, that's my sample that I would then want to be able to apply to my population. Second option, I can do a stratified sample. And with that sort of sample, I'm trying to choose an equal number of students to fully represent the Carondelet and De La Salle community. So half my students would need to be from Carondelet, half my students would need to be from De La Salle. I'd need an equal number of freshmen, sophomores, juniors, seniors, etc. So one, I'm randomly sampling from the entire population. That's a random sample. Or I'm creating I'm creating a sample that is directly in proportion to my population, okay? And the goal of this is to make sure, like I said, that the data you can collect, you can apply to your entire population, okay? Otherwise, you're gonna have something called sampling bias, which means that your sample is not representative of your target population. So if, for instance, I only surveyed lacrosse players, or I only surveyed company kids, or I only surveyed students that sit in the quad at lunch, obviously none of those are possible because we're online, there'd be bias, okay? Because there are certain demographics of students that do those activities, but they certainly don't represent all communities on campus. So I hope that makes sense, and we're gonna definitely keep that conversation going as we look in research methods throughout this unit and probably throughout the entire year. All right, so we are now going to hit on correlation, a super important concept that I'm going to do my best to explain this way. And once again, we're going to keep talking about it both in class and in some of the work that you're going to be doing. So a correlation is the measure of the extent to which two factors vary or change together. Okay, so we're looking at, do different variables impact one another? So let's go to some examples. Study time and grades, okay? Two variables, one is study time, one is grades. I would predict that as study time increases, grades also increase. Here's something that a social scientist might want to research. Do cities where there's large numbers of gun ownership, does it increase or decrease the murder rate, okay? So a social scientist might look at a particular city, they would take a random sample of citizens living there, they would survey them to know about their gun ownership, and then they would study that against the murder rate of that city, okay? So then they could predict as the level of gun ownership increases, would they predict that murder rates would go up or down, okay? I'm not gonna even begin to touch that hairy topic. Another thing that might be interesting to look at is self-esteem and depression, okay? Unlike study time and grades, which probably go up together, more you study, the better your grades are, self-esteem and depression go in opposite ways, theoretically, right? So let's say we would predict that as self-esteem increases, depression actually decreases, okay? And we're gonna use that as an example next. This last and very bogus correlation is something that we're going to come back to, okay? So let's just pause on that and we'll be back in a bit. So variables are anything that varies, aka changes, and we can measure. We can measure study time. We can track the hours. We can track your grades through your GPA. We can look at murder rates by looking at different data that counties provide, for instance, okay? So a variable, it's gotta be something that we can measure, otherwise we really can't do a study on it. All right, let's get more down to like the bare bones of correlation. So correlation is typically depicted visually on a scatter plot. These are scatter plots. You've probably seen them at math at some point in your life, okay? Good news for this class is we don't actually need to know the mathematical formula needed to create the correlation coefficient, okay? That is the flow on this scatter plot here. However, you do need to know sort of the different types of correlation. So correlation is on a numerical scale from 1 to -1, okay? And here's what's tricky. You might think a negative correlation or a -1 is not good. That's actually not true. A 1 and a -1 are perfect correlation. So the closer your correlational coefficient, try to say that fast, is to 1 or -1, the stronger your correlation is. Okay, so a -0.9 correlation is stronger than a positive 0.5 correlation. Okay, so try to let that sink in. Take a second to look at that spectrum right here. Okay, so the strength of the correlation is determined by how close to the number 1 or -1 your correlation coefficient is. Now, there's two types of correlation. There's positive correlation and there's negative correlation. Positive correlation is when your two variables move in the same direction, either up or down, right? For the example of study time and grades, we predict that they move in the same direction, right? More you study, higher your grades are. A negative correlation is when your variables move in opposite directions. So that might be the example of the self-esteem and depression. We predict that as self-esteem goes up, depression goes down. So that's a negative correlation. It doesn't mean it's bad. Negative does not mean bad. It means that your two variables travel in different directions. Okay, as one increases, the other decreases. All right, so let's come back to the ice cream and the sunburn. Okay, let's say that I do a study where I actually go out and I collect survey data and I want to know about ice cream and sunburns. And let's say I get a perfect positive correlation from my data, okay? So as sunburns increase, ice cream sales also increase, okay? So hopefully that hits your ears as pretty bogus compared to like study time and grades, okay? So it's always important to recognize that just because you have a correlation doesn't mean that one thing causes the others. We know that buying ice cream doesn't cause sunburns, okay? So it's always important to look at data with a critical eye. There's probably in this case a third variable, and that is that it's actually hot weather that causes both. So as a social scientist, you want to look at data through a critical eye, right? That's one of those things, the critical thinking piece. We know that just because I got sunburned didn't mean I have ice cream, just because I have an ice cream didn't mean I'm sunburned. A critical thinker would say, hey, look, there's another variable here, okay? So it's important when you're looking at someone else's data and they find a correlation, can we say, yeah, that makes sense. I think that those two things probably go together. Or wait a second, I think that there might be another factor that's involved here, okay? So that's an illusory correlation. And that's when we perceive a correlation and it doesn't really exist. There's a third variable that we really need to account for, okay? So from this, really important, I want you guys to know the idea of picking a really good sample size in your research, this idea of correlation, strong positive correlation, strong negative correlation, and this really important idea that correlation and causation are not the same thing. Just because ice cream sales and sunburns are correlated does not mean that they cause each other, okay? So it's that idea of having a critical mindset when looking at data and research questions. All right, we're gonna stop there. We will pick up in our next video talking about experimentation.